the design of our universe is actually biased in favor of the emergence of not just life, but intelligent life. And our galaxy is believed to be an average-sized galaxy. There are some bigger, some smaller. In fact, there's a big one coming towards us that will collide with us. That galaxy is Andromeda. Andromeda is estimated to contain 1 trillion stars. Planets that are within what we call the Goldilocks zone, not too hot, not too cold. Generally, that's planets that are at a certain distance from their star, which enables them to have liquid water, at least part of the time, or underground, or whatever. And that is believed to be a likely prerequisite for life. Mm-hmm. But there's a far more important prerequisite. That is having a decent-sized moon. The moon is absolutely critical to life. Now, for example, imagine you're on a Starship Enterprise, and you're coming into the solar system 4 million years ago. Mm-hmm. Sorry, 4 billion years ago. You would see a beautiful blue-white orb amongst the planets. That would have been Mars. Because Mars had a molten core at that time. Mm-hmm. It had its magnetosphere, and it had an atmosphere, oxygen-rich.
The title of this episode is "The Design of Our Universe is Biased Towards the Emergence of Intelligent Life."
Yes, it's a slightly odd title. I think viewers will be intrigued. So I claim that the design of our universe is actually biased in favor of the emergence of not just life, but intelligent life. That is, I think, quite a statement. Now, just to recap a little bit, I think many people get confused about stars and galaxies and universes, etc. So just to simplify, everything that we can detect, the totality of existence that we can detect, is our universe. Some theoretical science models involve equations that call for multiple universes. But on a factual basis, we have no information suggesting there's anything beyond our own universe. So I stick to that. It's quite big enough. The diameter of our universe is currently estimated at 93 billion light years. That's quite wide. Now, to put that in perspective, there's a nice easy number to remember, because our sun is 93 million miles from Earth. So 93 crops up in both times. Mm-hmm. Now, it takes light 8 minutes to journey from the sun to Earth. 8 minutes. Mm-hmm. If you assume that we're somewhere in the middle of the universe, that means it takes 46 billion years for light to reach the edge of the universe. And we don't know of anything that moves faster than light. So we're in the middle of a very big place. To give some more data, how many stars are there? Mm-hmm. Let's look first of all at our own galaxy, the Milky Way. The estimates are that there are between 200 million and 300 million stars in the Milky Way. You might say, well, that's a bit vague, and we got a more precise figure. The problem is we have a reasonably hard number for the total mass energy of our galaxy, but counting the individual stars is a bit more tricky. So there's a bit of a band in there. And our galaxy is believed to be an average-sized galaxy. There are some bigger, some smaller. In fact, there's a big one coming towards us that will collide with us. That galaxy is Andromeda. Andromeda is estimated to contain 1 trillion stars. So it may be 4 times as many stars as we have in our little galaxy. But don't worry, don't have nightmares about it. Impact date is about 4.5 billion years from now. So it's a long way away. It'll be a wild ride when the galaxies merge.
So they will merge. It's like they will collide as a whole, right?
There'll be a dance. We've witnessed it with other galaxies.
Right.
Maybe some stars will actually collide, but the majority, because they're so spread out. I mean, our nearest star, Alpha Centauri, is about 2.5 million light years away. So it's not as though so many stars are going to be hitting each other, but the gravitational forces will be immense.
Closer
and the risk is for life forms living on planets going around the star. You get a massive star coming anywhere close, they're going to be torn out of orbit.
Wow.
So that's goodbye, good night.
Yeah.
Since I've been writing, it's about 10 years, the estimate of the total number of galaxies in the universe has increased from around 10 billion to 2 trillion.
Whoa, that's a big one.
This is the benefit of some new Earth observatories that have been commissioned over the past few years, particularly in South America, and also, of course, the James Webb Space Telescope that's updated and replaced the Hubble Space Telescope. So now we detect infinitely more galaxies. So to answer that earlier question, how many stars are there in the universe? It's actually 2 followed by 22 zeros. Quite a lot. Interestingly, I can remember when I was a teenager reading that serious scientists suggested that maybe our star is the only one with planets. And this, of course, was a distinct mark of God's blessing of humanity to give us a home where we had a series of planets. And this is a mark of benevolence and the fact that mankind was the pinnacle of creation. Now we know that's not quite true. But there is something truly amazing about this vast number of stars. It seems that the fundamental design of the universe is the creation in untold multitudes of a 3-part model of stars, planets, and moons. Each is critical. A star, of course, is a fusion reactor. It generates heat and light, without which there's no life. The formation of the star automatically, we now understand, automatically creates a series of planets. The lighter stuff, hydrogen and some other elements, will fill up the star. Some of the heavier elements and other stuff will be circulating in an elliptical plane to minimize the amount of collisions that take place. Plenty of collisions do take place, but at least at formation, all of the material orbiting a star should be on the same plane. And gradually, that material will clump or collide into bigger lumps that become planets. Planets that are within what we call the Goldilocks zone, not too hot, not too cold. Generally, that's planets that are at a certain distance from their star, which enables them to have liquid water, at least part of the time, or underground, or whatever. And that is believed to be a likely prerequisite for life. But there's a far more important prerequisite. That is having a decent-sized moon. The moon is absolutely critical to life. A moon makes sure that the metallic molten core of a planet remains molten, remains liquid. The gravitational waves exerted by a moon as it orbits a planet, in effect, slowly stir that molten core. By keeping that core molten, the planet maintains a magnetosphere around the planet that deflects much of the harmful radiation from the cosmos and from our own star. By maintaining a magnetosphere, it also retains the planet's atmosphere. Without that, if you have your core cool and solidify, you lose your magnetosphere. Most life will be irradiated. You lose your atmosphere. You've lost any chance at terraforming because there's no atmosphere, there's no weathering, so there's no ecosystem.
Without the moon, we have no shield.
That's right.
We are completely unprotected.
Now, for example, imagine you were on a Starship Enterprise, and you're coming into the solar system 4 million years ago. 4 billion years ago. You would see a beautiful blue-white orb amongst the planets. That would have been Mars. Because Mars had a molten core at that time. It had its magnetosphere, and it had an atmosphere, oxygen-rich, which is why we call it the red planet. Because all that oxygen in the atmosphere oxidized, exposed iron on the ground. At that time, if you were on Starship Enterprise, you would have ignored Earth because your detectors would have told you that the surface temperature on Earth was about 2,000 degrees centigrade. So not only granite and basalt would be liquid, so would lead, silver, iron, copper, all liquid, sloshing around with anything else that's liquid at that temperature. So no one would have stopped for a moment to think there could be any life emerging on Earth. Unfortunately, about 200 million years later, about 3.8 billion years ago, Mars' core froze. It has 2 little moons, but they're tiny. Their diameters are like 5 kilometers and 10 kilometers.
Really tiny.
They're tiny.
Yeah.
So they were unequal to the task of stirring the core.
Right.
Core froze, radiation came in, atmosphere bled away.
Hopefully there was no one living there.
No.
Hopefully.
Well, it's interesting to speculate because if we'll come on to this in a later episode, it's entirely possible that some very primitive form of life could have emerged, and plenty of meteorites from volcanic eruptions or meteor impacts on Mars have been thrown out of orbit of Mars, and some have landed on Earth. On Earth, we have meteorite samples from Mars. So they could have carried
life. Yeah.
They could have carried amino acids, they could have carried DNA.
Yeah.
Everyone's seen the film Prometheus.
I watched it, yeah.
So some very interesting ways, in fact, that Hollywood is almost coming up with stuff which is at the boundary between science fiction and science fact.
So do you think humanity will be able to colonize Mars?
I know that Elon Musk is looking at this. He's set his heart on being able to send his rockets and colonizers to Mars. I wonder if he knows, surely he should, that Mars has no magnetosphere, which means firstly, colonists will have to remain under shields the whole time.
The whole time, yeah.
And secondly, the idea of cultivating, growing crops that absorb carbon dioxide and expel oxygen to create a livable atmosphere is for the birds, because there's no magnetosphere. If it does produce anything, it would bleed straight off into outer space.
Right.
So it won't be very hospitable.
People say we should make what we are doing here on Earth, pollution and all that, to give it an atmosphere. Is that accurate?
Well, the problem is you can't have an atmosphere on Mars because there's no magnetosphere, and that's because the moons are too tiny.
Yeah.
And we'd have to heat up the core. What we'd have to do is get hold of a very big space rock, put it in orbit around Mars.
Oh, that's interesting.
And then warm up the center of the planet. That would be quite a task.
Yeah.
Then we'd be off. We'd be off and running then.
Yeah. So what about our moon?
We were very lucky because it seems at the beginning Earth had no moons. Generally speaking, inner rocky planets don't get moons, partly because they're not strong enough their gravity is not strong enough to capture movements because they're too small. The sun's gravity is a bit greater, and it's closer than it is to, say, if you're a gas giant that's further out in the solar system. So the inner planets basically don't have moons. Mars has only managed to get 2 tiny ones. And it was competing with Jupiter, not that far away, that's got 130 moons or something. But it's very interesting the way the theories have evolved as to how we got our moon. I think the emergent consensus view today is that a large, very large object impacted Earth when Earth was maybe 50 million years old. If you look at the lifespan, and we'll come to this in some other episodes, if you imagine the life of our planet as 100 years, then it's a nice, easy way of measuring some things. So if we say on Earth's first birthday of its 100-year life, I'm talking rough dates, it was hit by something very big, which, because of the way it impacted, and this has been subject of a lot of mathematical modelling, is likely to have expelled matter from the far side of the Earth. And that matter became our moon. There's a number of things that support the theory. Firstly, what we've found, all the rock samples we've found on the moon, we've found corresponding samples on Earth. Not just granite or basalt, but we found the exact isotopes, which means that those rock layers were laid down in the same place. The signatures, the isotopic signatures of particularly volcanic rocks, are very, very specific. So if these rocks formed in the same place, the moon and the Earth must have been the same at one point. Something, if you model it, it shows clearly a big enough object hitting the Earth could expel material the other side that became our moon. The question is, okay, if something hit the Earth, what was it and what happened to it? What has been puzzling seismologists for a long time is there are 2 extremely large objects buried around 3,000 kilometers below the surface of the Earth. These go by the strange name of LLVPs, large low velocity provinces. And they show up as a significantly different density just above our inner core. And people believe, because of the mass, that these represent the remains of the object that hit us. You could also imagine that our earliest understanding of when we had a single continent, we would have been a planet with basically sea on one side and a giant continent on the other side. They could be completely unrelated, but it might sort of fit that you have a big impact on one side. The land is pushed a little bit out. So our planet is not completely circular, not round, it's actually a bit bulged on one side. The sheer size of our moon relative to Earth, I think, makes it almost impossible for Earth to have captured it. When if the moon was just flying by, our gravity would not have been not strong enough to have captured an object of that sheer size relative to our own. So it must have been captured in a different way or formed in a different way.
But the moon is still trying to leave us, right?
Yes, it's moving away.
Moving away.
Yeah. It's been with us for nearly 4.5 billion years, and we've got about the same amount of time left. Okay. So it's certainly going to be with us for
a long time,
a few billion, beyond our lives anyway. It is true. The types of eclipse that are happening now, it's believed these are some of the last that will be seen, where you have the ring of fire. In the past, an eclipse would, the moon was close enough to completely cover the sun. Now we're getting more where you just see the little ring of fire all the way around the edge, which it looks stunning. As the moon's orbit becomes greater and greater from Earth, so it will shrink in size, so the full eclipse and the ring of fire will become less frequent and then be gone forever. But it'll always be an angular one where you see a big ring of fire around the outside. So that would be a shame.
Better enjoy it while it lasts, right?
And actually, talking about the moon brings us to a staggering historical record, which opens up lots and lots of questions. Earlier I mentioned the Sumerians. This is the empire, basically Iraq, which existed at least by 4000 BC and died out about 2000 BC. I think most people will be familiar with Abraham and his father taking him out of the capital city, about 2000 BC. Now, the Sumerian historical record is that they believed a very interesting record of how our moon was created, which has come full circle to what our cosmologists currently believe. They believe that there was a planet orbiting between Mars and Jupiter that they called Tiamat, which means basically the watery planet, because they believed it had very deep water all over it. This planet was hit by another planet which has a highly elliptical orbit, which they called Nibiru. Now, indeed, today there are quite a lot of cosmologists who are looking for another planet that we haven't yet discovered that spends most of its time way out beyond Pluto, but has a very elliptical orbit. That is what the Sumerians believed went very close to, or actually demolished, Tiamat. The result was the greater part of that planet, maybe a half of it, then collided with the Earth. The remainder formed what we call the asteroid belt, which interestingly, the Sumerians and other subsequent cultures, including the Israelites, called the hammered bracelet. There hangs a tale, which we'll come to in another episode. But the Sumerian record is startlingly similar to what conventional astronomers now suggest. Another planet hit ours. The moon was ejected from the original Earth, which absorbed this big chunk of a very watery planet, which bestowed on us a vast amount of water vapor and water. Interestingly, we've had two incidents which have corroborated the fact that our seawater could well have come from objects that are now in the asteroid belt. We had a space probe that took a close sample of moisture from Ceres, which is the biggest asteroid in the asteroid belt. And that showed a particular form of salty water, almost identical to the chemical composition of Earth's seawater. Very strange. We also had a small meteorite that crash landed in southern England about 5-10 years ago. And on impact, it's on somebody's front drive, a lot of the material was gathered up, and when it was analysed, they found, wow, again, it contained elements of a watery compound almost identical to Earth's seawater. Mm-hmm. So it suggests maybe our seas were stocked by asteroids with a lot of seawater in them. Mm-hmm. That sounds very far-fetched, but if a big chunk of a planet with a lot of seawater collided, That also sounds quite plausible. So those are very interesting, very ancient and very modern stories which almost coincide explaining how we got our moon. I think that's probably what we've got for you today. We'll be back with the next episode going online very soon. Thank you very much.